So in this math, we're asked to develop a recession curve, and from that we'll obtain the recession constant and recession equation. So you have seen the hydrograph, flat hydrograph. Uh, if this is say time, this is q. It goes like this and it falls like this. So from a particular point, let's say from here, yeah, it's kind of a straight line. It's a constant. It has a constant slope, and the slope is called the recession constant, I guess. And we'll actually develop a equation for this part. So for this part, we have equation like q t is equals to q naught kr to the power t. Here the kr is a recession constant. Let's say we have taken ln in both parts, so you'll get ln q2 is equals to ln q naught plus t ln kr. So from here, we'll assume that ln qr is our y and t is our x, and this is our m slope, and this is our c. So we'll say that this is our k and q, and you'll find it ln qr. We'll take ln here, and for the ln, we'll get a value of like 7.6, 7.6. These are some manipulated data. If you plot them in a paper, it will not deflect much. Now we have a curve over here. Sorry, graph paper over here. We'll draw here. Let's a bit. Let's say this is your point. Let's say this is your origin. This is 5. This is 10. This is 15. This is 20. This is 25. Will not go much. So this is 1, 2, 3, 4, 5, 6, 7, 8. So these values are for ln qt. Sorry, qt, right? And these are your time in minute, probably minute or anything else. Whatever be the unit, these are times. So for time 10, you got a value of 7.6. So this is 6, 7.6, this is 7. So 7.6 will be 3 more units up. So this is the point. For 11, let's say we'll get another point. Let's say for 15, you get a value of 5. So this is this. This is the point. And so for 20, you get a, 20 is the 20. Yeah, 20, you get a value of 3.76. So this is 3, and 3.76 would be somewhere over here, somewhere over here. And you can see the change of slope here. we'll find the changes there. Let's draw the immediate next point, which is for 11. So 11 is here. So for 11, you get a value of 6.9. So this is 6. 6.9 would be somewhere over here. And let's say for 13, you get a value of 5.5. So this is your 11, this is 12, this is 13. So for 13, you get a value of 6 point, sorry, you get a value of 5.5 for 13. So for 13, you get a value of 5.5. So this is 5. So 5.5 would be middle of it. So this is 5.5. So here you can actually visually see the change in slope. We need that. And for 14, you get a value of 5.25. So this is 13. Maybe this is 14. This is 14. And 14, you get a value of 5.25. So this is 5 and 5.25 would be somewhere over here. Somewhere over here. So this was for 13. We'll not draw more points. Let's say we can draw a few more points. Let's say 15. We have drawn that. Let's say for 17. This is 15, 16, 15, 16, 17. 17, we get a value of 4.5. So this is 4 and this is 4.5. So from here, you can see that the first straight line will go like this, and the second straight line will go like this. Will go like this. So, what I'm saying, we have a slope separation somewhere over here, maybe here. So let's say the value is 5.5. So where the slope separates, and for that we get a value of q, ln q. We call that ln q naught, and that is 5.5. From here we can get the value of q naught, which is e to the power 5.5, and that will generate a value of 245. Again, we need slope. Let's say we take point. Let's say we take point of mm, a point. Let's say here you can see that this point is 19 and 4, and let's take another point. Let's say 15. This 15. For that 15 comma, this point is around 5. So from here you can get a slope of 4 minus 5 and 19 minus 15, and you get a value of minus 0.25. So and it's actually the value of ln kr. So from there you can get the value of kr as e to the power minus 0.25, and it will generate a value of e to the power minus 0.25, 0.78. So your equation is qt is equals to q naught, which is 245, and kr, which is 0.78, 0.78, and you have a time. So keep in mind that when you find discharge in recession slim spurt, you'll put the value of t cautiously. That is, let's say we are asking to find out the discharge at 20 hours from the starting, which is this. But you cannot put the value of t is equal to 20 directly. You will put the value of t from where the slope separates. Here the t will be this. So this would be your 0 point. So up to this, let's say it's a point of around say and 12.5, maybe 12.5. So your t will be 20 minus 12.5. So for that you'll get a value of q from that equation.